Hi dear students, today we'll discuss the third chapter of class 9, that is laws of motion. In the previous part we have discussed about motion. We have learned what is motion. The motion tells that when a body change its position with respect to some fixed frame of reference, that is known as motion. There we have learned about the types of motion, equations of motion. Now we'll come to know what is the cause of motion, why a body will move. So when this type of question has come, the one and only answer that come to our mind, that is force. Force is responsible for motion, that we know. So here, whenever we are talking about force, we have to define it. What is force? Now it is a physical quantity. You all know it is a physical quantity, comma, by which we can able to change the shape and size of a body and the state of rest or motion. So that is force. It's a physical quantity by which we can able to change the state of motion, that is change of state of rest or motion, or we can able to change the shape and size of the body. That is force. I don't think it should be explained more because you have learned it earlier also. Now we have to directly go on to the types. How many types of forces are there? Generally, there are two kinds of forces are there. One is known as contact force. Another one is known as non-contact force. Contact force and non-contact force. Let's see some example of contact force and non-contact force. But before that, we have to define it. What is contact force? Now, the contact force is a kind of force which needs a physical contact. Physical contact to apply a body. Means to apply the force on a body, you need to apply a physical contact. Just like if I apply force on the board, I have to touch the board. That is a contact force. If I want to pull something, if I want to push something, if I want to apply tension to a body, we need to apply a physical contact, and that type of force is known as contact force. Okay, now coming to the next part, what are the example of it? Let's discuss about the example of contact force. First it is coming frictional force. It's very common thing and we are very much aware of that also. What is friction force? Now if a body moves or tends to move over a surface, then this surface is opposing the motion of the body. Example, assume this is a body. I am applying force here to move the body. But as the body moves through the surface, this is the surface. Okay. Then this surface apply a opposite force to the body. That opposite force is known as frictional force. So frictional force is an opposing force which just try to stop the motion. Okay, and you see it is only possible if the body is contact with the floor. If it is not, then the frictional force will not be applied. So frictional force is a contact force. Frictional force is a contact force. Now we have to go to the next. That is normal reactional force. Normal reactional force. What is normal reactional force? That we'll learn too much clearly later. Here we have to learn a little bit. If I put a body on an object or on a surface, okay, if this is a body, I have just kept it on a surface. This body will apply a force in downward direction. Assume if I hold, just example, this is a diary. If I hold it like this way, okay, so the weight, the diary is having a weight, it is acting downward, because if I leave it, it will fall and down. So the weight of the body is acting downward. As the weight of the body is acting downward, there is a reactional force is acted by the table, or if I hold it by my palm, so this pump will give a reactional force to the diary or to the body in perpendicular direction upward. So as it is a reactional force, so it is known as reactional force, but it is acting, you see, normally, perpendicularly. That's why it is known as normal reaction force. And here also it is clear, until unless it is touching with a surface, this normal reaction cannot be applied on a body. Okay, so we can say normal reactional force also, it is needed to be physically contact with another body, then only it is applied. Okay, and that's why it is known as a contact force. Now I'm going to the next part, that is tensional force or tension. What is a tension? Try to understand it, because you will need this concept later also. Tension or tensional force. What is it? Assume if you hung a body from a ceiling. Okay, if you hang a body from a ceiling by a thread or by a string. So here this body, the force applied on a body due to the gravity, it is acting downward, and we know that force is known as the weight that is acting downward. And on that thread or string there is a tension acting, and that tension is acting in upward direction. Okay, tension is always acting in upward direction. This is also one kind of reactional force. I am making you clear what is reactional force, what is action, that we have to learn whenever we have gone to learn the Newton's laws of motion. Then I will make it clear. But keep it remember that the weight is acting downward, and due to that weight, one reactional force is acting on the thread, that is known as the tension. Tension is denoted by T. If this thing is in equilibrium, means the body is not fallen by cutting the string. If it is not fallen, if it is hung continuously, then we can say T equals to W. Tension should be equal to the weight of the body, and that also is possible if it is connected with the body. So tensional force is also compulsory needed to be physically connect with another body, otherwise the tensional force will not come in. Okay, next we'll go for force due to the spring. Force of spring, I'm writing here spring only. So spring we all know. Okay, so this type of thing. Okay. Assume if you are applying a force here, the spring will compress, and for that the turning will come together. Okay, and if you release it, it will again move here, because we all know when it is compressed, there a potential energy is stored. When it is released, it is coming outward. So this type of force which is applied by spring, here also a physical contact is needed. So it is also a contact force. Not only that, the next thing, if I'm talking about collision, So it is also just like the same thing. That's why I'm writing together. Collision means, assume two bodies are moving in the same direction. Okay. After certain time, if this body is just connect with the first body. Okay. Have you played with the marbles? Many village children still now they have played. We are also, whenever we are in our childhood days, we have played with these marbles. But nowadays everybody is watching Marvel rather than playing with marbles. Okay. Forget about that thing. So here we have seen the collisions. Forget about the marbles. Have you seen the billiard balls, the billiard playings in mobile games? I think you have seen. So there also you have seen two balls come closer together, collide together, and they move in separate direction. So this type of collisional force also, it needs a physical contact. Without physical contact, this force cannot be applied. Okay. Now going to the next part, non-contact force. What is non-contact force? Now, if a force is applied on a body without physical contact, without physical contact, here physical contact is needed, here without physical contact, very common names are there. Number one, magnetic force. We know, if I'm talking about magnet, there are two poles, north pole and south pole. If the opposite poles come closer together, they attract. If the same poles closer together, they repels. And here one thing you see, I think no need to give any example, you have seen it earlier also, that this attraction and repulsion doesn't need any physical contact. Without physical contact also, they can apply the force to another body. Okay, so that is a non-contact force. Not only that, if I am talking about the gravitational force, gravitational force is, we will learn detailing on gravitational force on this chapter only, but here I am just giving an example. See, all of us are attracted towards the earth by the force of gravity. If we jump from a height, we'll reach at down. So it is not like that we'll move upward. It is not possible. So the great scientist Newton has shown that the apple is fallen downward when it is just falling from the tree. Okay, so it is not for the apple, it is for everyone. If you coming from the, if you just jumping from a height, you will reach downward. That is the gravitational force. And interesting thing is that here also you don't need to apply any physical contact. Okay, when you will reach the ground, then you physically contact with the ground, then there will be some problem. But for the application of force, no physical contact is needed. Coming to the third, this is a new name for you, that is electrostatic force. See, electrostatic force is little new word for you because you have not learned about the electrostatic force. I think you have learned little about the charges. Okay, in class 8 only, in the last chapter, you have learned about the charges. So charges are the intrinsic property of the elementary particles. Okay, so here these elementary particles, the charges we are talking about, there are two kind of charges, one positive, another one is negative. So we know same kind of charges will repel each other, and opposite kind of charges, they will attract each other. So there is the electrostatic force is acting between them, and there also no physical contact is needed. Okay, so these are the examples of physical contact and non-contact force. This is the introduction part of laws of motion. Now we will move further. What is the law? We will learn it. And who has discovered the law? Though these laws are in the name of great scientist Newton, but to make the law, many more scientists are helping him. Newton has arranged him and calculate it very nice way, but many scientists have already worked in this case. If I'm talking the first name, that is the father of modern physics, Galileo. Okay, so Galileo has shown one thing, that earlier peoples or earlier scientists, they have thought, if I want to move a body or if I want to make a body, it will come in motion, we have to apply a force. And if I want to stop it, then also I have to apply force. If I want to make the body always in motion, if we need that the body should always be in motion, then also we need to apply force. Initially they have thought that. And our thinking is also like that. Assume you are cycling, until you are applying the pedal, your cycle is moving. If you stop it, after certain distance, the cycle will stop. So the scientists have thought the force is one and only thing which is needed to move a body continuously. But scientist Galileo has given a very interesting thing. What? Let's see. He has told, if I want to make a body come into motion, then I have to apply force. If I want to stop a body, then also I have to apply force. But if a body moves, with a constant velocity, there no force is needed to be applied. Then you think, sir, so our practical example is totally different. If I applying paddle to a cycle, then only the cycle will move. If I stop the paddle, the cycle is also stopped. Galileo has told the cycle is stopped due to some another opposing force is acting on it. Like when the cycle is moving, okay, when the cycle is moving, okay, then a frictional force is acting on the wheel, which is just right to opposing the motion of the cycle. If we think that frictional force will not apply, then it will cover much distance. We think, yes, if we just move our cycle in a plain path, then after stopping the paddle only, oh, we have forgot to draw the paddle. So without paddle, how the cycle can able to move? So if I stop the paddle only, then it will cover more distance. But if you move in a road, there are much more gravels are there, then if you stop the pedal, after moving certain distance it will stop. That means one opposing force is acting on it, that's why it is stopped. If you are not given any opposing force, then the cycle will move and move. That means to make a body move, we need to apply force. When we want to stop a body, then also we need to apply force. But if a body moves with a continuous motion, then no force is applied until a frictional force is applied. That's why it is stopped. If I'm talking about the fans, if the fan moves, okay, I need too much, because see, for doing the video, I'm off my fan and see my condition, what is going on. So if I on the fan is moving. When I off, after moving little bit times, it will stop because of the frictional force, because of the opposing force given by the air. If this force is not applied, then the fan will move and move. Okay, so this is Galileo has told, and Galileo has given a conclusion that if a body is rest, the body try to be in rest situation. If the body is move, it just try to move continuously in a straight path until a force is applied on it. And that idea of Galileo is taken by Newton and applied to the first law of Newton, that is first law of motion, that is Newton's first law of motion. Okay, So make a heading, Newton's first law of motion. According to Newton's first law of motion, if a body is at rest, it try to be in same state, and if a body is at motion, it tries to move continuously in straight path unless an external force is applied on it. That means what Galileo has told, that is been taken by Newton, and don't think that Newton has taken only the thing from other person. Newton has also given many more things, but he have arranged the thing in a very nice manner, where it is told if a body is at rest, it try to be its same state, means it try to be at rest. If the body is in motion, it tries to move continuously in straight path unless an external force is applied on it. Unless an external force is applied on it. That is Newton's first law. Okay. Now, there is a conclusion from Newton's first law. What is the conclusion? Now, by that law, what we get from this law? From this, we get number one, definition of force, and number two, idea, not idea phone, idea of inertia. These two things. First one, you know that. Second one, we need to explain more on that. Definition of force we have got from first law of motion. Now you can ask, sir, we have already defined force earlier, then why we have to define again? No, we are not defining again. We are just giving the idea of force in the light of Newton's first law of motion. What is the definition? Just listen it properly. The definition of force should be that force is a physical quantity by which it can able to change the state of rest or change the state of motion unless the body will be in a same state. What I am telling, that by the application of force we can able to change the state of rest or the change the state of motion unless the body will be in a same state of motion. That is force. Okay, so by the light of Newton's first law we can able to define the force. Okay, next one is a very important thing, and for that I want to erase everything. That is inertia. What is inertia? That we have to explain. Okay, so two conclusion from Newton's first law of motion. One, there is the definition of force, and second one, idea of inertia. What we have seen? We have seen if the body is in rest, it just want to be in a state of rest. If the body is in motion, it just try to be in a state of motion in a straight line. This is a property of a body. Property tells us that the body try to be in a same state where it is. So what is it? The inertia, it is a property of a body by which it tries to be in same state or oppose the change of state is known as inertia. Very interesting thing. This is the property of the body by which it always try to be in same state. See, if I am talking about a brick or a stone, if you keep it one place at your room, you will go for 10 or 20 days for a long tour. When you will come, you will see the stone or the paperweight or whatever the thing is there in the same position. Means if the body is rest, it always try to be in rest. Now you can ask, sir, if the body is in motion, it will not always be in motion. It stops. Yes, it stops. But why? It stops as the opposing force is applied on it. If the opposing force is not there, then the body will move. If I'm talking about the universe, if you go there, if you throw a ball, it will move. Okay, nobody can dare to catch it. No MS Dhoni, no Virat Kohli is there. The ball will move, move and move. Okay, so this is inertia. What kind of inertias are there? Number one, there are two kinds of inertia. One is inertia of rest, and number two, inertia of motion. Apart from these two only, one thing we have taken, though it is not written in your book, but in some other book it is mentioned, that is inertia of direction. Why it is not written? Because this inertia of direction, it is just coalish with the inertia of motion. Okay, so some book it is taken into three, but mostly there are two parts: inertia of rest and inertia of motion. What is inertia of motion? Rest. The inertia of rest is that by which property the rest body always try to remain in same state of rest, that is called inertia of rest. That is property by which a body try to be in state of rest. That is inertia of rest. Okay, example we'll discuss. If I'm talking about inertia of motion, then we'll discuss the examples. Don't be panic. So inertia will be the property by which a body tries to be in state of motion. So it is a property by which the body try to be in state of motion, that is inertia of motion. What is inertia of direction? Now it is a property by which a body tries to move in same direction, that is known as inertia of direction. See, inertia of direction, it is specially, you see, it is a part of motion only. That's why in some books it is not mentioned. Okay, so I have told you, if you have not mentioned, if it is asked what types, how many types of inertias are there, so you can mention only inertia of rest and inertia of motion. So for another case it is not needed. Okay, now we'll just learn little bit of example of inertia of rest and inertia of motion. Okay, let's see. We're discussing about the example of inertia of rest. Okay, first example you have to discuss here. So first example is whenever a vehicle gets start, suddenly then we will feel that we are just moving backward. Whenever a vehicle, it may be a train, it may be a bus, it may be a car or a bike, when starts suddenly and move forward, we are just supposed to moving backward. Why? What is the reason behind that? That we just want to see. So assume if a person, okay, standing at the floor of a train or maybe a bus, okay, so when it suddenly starts, as the person is standing here, so he is or his body is in inertia of rest. Okay. When it starts suddenly, when this platform moves, then the lower portion of the body, you see, this lower portion of the body, they just go with the platform because they are coming into the motion. But if I'm talking about the upper portion of the body, they want to be in same state of motion or same state of rest, and that's why they are not moving, and that's why your lower part is going here, but your upper part of the body is just try to remain in same state, and that's why it seems to be that the passenger is moving backward, and that is an example of inertia of rest. Okay, not only that, whenever we just want to wash or clean the carpet, the quint, then you see your mother or your father just put it over the roof on a rope. Okay, just hang it like this way and then beat it by a stick. Then you may think what problem it has made. Okay, any nuisance is made by that carpet. So why we are beating the carpet so hard? We are beating because we know inside the carpet there are huge number of dust particles there. So as we beat the carpet, then what will happen? You know, the carpet will move, but the dust particles, they cannot able to move due to the inertia of rest, and that's why you hit it, the carpet will move and dust particles are coming down, and by this way we can able to clean the carpet. Okay, because if I want to wash it, so it is a very huge task, but rather than it is easier to beat, always it is easier to beat someone. Okay, though it is not good, but if you beat it very hard, then the dust particles are falling down. That is also one example of inertia of rest. Not only that, one very good example is there. You can do it in your home also. Take a glass, take a postcard like this. Okay, so just use a hard one, then you can able to see it. If I get time, I'll show the video of it also. Okay, I can do it, but here now it is little difficult. And put a coin here over the postcard. Now you apply force by striking. Okay, like carom, you are strike. So like striker, you just hit here. You will see the postcard will go and the coin is falling downward on the glass. What generally we think what will be happen, or what we think it will happen, we think when the postcard will go, along with the postcard the coin will also go, but it is not occurred, because as you apply force on the postcard will get motion, and that's why it moves, but the coin is in the state of rest, so it just try to be in state of rest, and that's why it comes downward. Okay, these are the example of inertia of rest. Many more examples are there in your book. Go through it. I think you can able to understand. Coming to inertia of motion, it is also very interesting. Inertia of motion, and here also we have to see some of the example. Inertia of motion. Example number 1. Similar, when we are talking that suddenly a train or a bus apply brake. Suddenly a train or a bus or a car apply brake. Then all of us, we just fall in forward direction. Why? Why it is occurred? Okay, assume a person is standing on a platform of the, not platform, means the floor of a train. So as the train is moving with a uniform velocity, so that same velocity is there for the man also. If the train is moving with a velocity of b, so man is also moving with the same velocity of v, and suddenly when the brake is applied, the floor gets stopped. And as the lower portion of the body is connected with the floor, just try to understand, lower portion of the body is just connected with the floor, so that's why this portion is stopped. But your upper portion, it is trying to move with the same velocity due to inertia of motion. We have learned what is inertia of motion. Inertia of motion is a property of a body by which a body which is in motion, it just try to be in same state. As it just try to be in same state, so that's why it comes forward. And that's sometimes we have seen the person fallen down also in bus if he is not holding the bar it is given at the top. If you are standing on the bus, if you are sitting also, you will just move forward, and sometimes your head is knocking, okay, you are just striking the another seat which is in front of you. So that time you always tell that hold the handle it is given at your seat, otherwise this type of accident may happen. Okay, so it is one example. Number 2, if I'm going for an example that whenever a person or a bowler or an athlete, they have to do any performance, just like throwing the ball, throwing the javelin, throwing the if I'm talking about whenever throwing the discus, that time they have to run a little bit. Whenever for the long jump, for high jump, the athlete has to run a distance. Why? They can able to jump by standing also. Why they have to run? One can throw ball by standing also, what we have played many times, that is the short cricket, we just ball by standing. But for long cricket, we know we have to run and then ball. Why? What is the reason behind it? The reason is that as the bowler runs, then the ball with the bowler, it is also moving with the same speed of bowler. Okay, when a bowler runs, the ball is also moving with the same speed, and that's why the ball is in a inertia of motion. The ball is in the inertia of motion, and that's why whenever you have thrown the ball, then the velocity or speed of the ball will be more. But if you have thrown the ball by standing only, then your ball is in state of rest. So the ball is having an inertia of rest. So whenever you have thrown the ball, you have to change the inertia from rest to motion. So for that case, some of your energy is lost, and that's why the speed of the ball will be less. But if the same thing you have done by running, then the speed of the ball will be more. That is same for javelin throw, that is same for long jump, that is same for high jump. Okay, that's why the athletes run before doing any sort of activities. This type of activities we have explained. One interesting thing of inertia of motion. Assume you are standing at the floor of a train. Assume that. It's a very interesting example. Okay. And as it is the last part, so the condition of my pen ink also, it is coming to the last position. So it is my last diagram. I think you can able to understand. Okay. So my diagram, I know it is ridiculous, but you have to understand. So assume a person standing is not doing any Hare Krishna or something like that. He is playing with the ball. Okay. On the train. The train is moving. Okay. He is throwing the ball upward and catching the ball also. Okay. So whenever the train is moving with a speed of v, okay, he is throwing the ball upward and catching the ball and doing in the train. Now you might be thinking, sir, why it is possible? When a man is thrown the ball, assume he has thrown here, so ball is going upward, but already the train is moving here because it is in motion. So the man will come here and the ball is fallen down. So why it will come to the hand of the man? It is not happened. Because as the ball is there on the hand of the man, so the ball is also moving in forward direction with the same velocity of train. So as the ball is thrown upward, you see, as the ball is thrown upward, so the ball is also trying to move in this direction. So it is going by this. And when it reaches here, the man already coming beneath the ball. Okay, so he can easily catch the ball. So that is also happened due to the inertia of motion, because as the ball is thrown by the man just like this, so when the ball is thrown, the ball is also getting the velocity v by which the train is moving. So it is not moving in a straight line and coming downward. No, it is going by this type of motion that is known as projectile motion or projectile. And when the ball has coming here, the man has already coming to this point, because as the train is moving with a speed and he can able to catch the ball. Sometimes the question is happened, is it possible when a man just throwing a ball inside a moving vehicle and catch the ball? Yes, it is possible, because with the man, ball is also in a state of motion, that is the inertia of motion, and that's why this thing is possible, that the ball will come to the hand of the man. Okay, so this type of examples are asked in exam also. One thing I'll mention, that is inertia of direction. I have told in many book it is not given, it is taken with the inertia of motion, but in many book it is given also. What is inertia of direction? The inertia of direction tells us that we want to move in the same direction where we are going. Assume a bus or a car. Okay, a car or a bus, it is moving in this direction, and suddenly it takes a turn. Okay, mainly it is happen in hilly areas when the cars or buses are going. So when it suddenly take a turn, we all know that we all move in this direction, we all bend in this direction, because as the car is moving in this direction, our body also try to be there in this direction when it takes a turn, but due to the inertia of direction it always just try to this direction, so we move. That is known as inertia of direction, but you can take it as the inertia of motion. It is happened when we have taken a sharp turn. We have just moved in that direction, in which direction we are going. Okay, this is inertia of direction. Though it is not important, the important part is inertia of rest and inertia of motion. So that part you will read it properly. That is the first part of class 9, laws of motion. Okay, so from next class we will discuss about Newton's second law of motion and third. Okay, thank you.